For decades, the men and women who studied American aviation history believed they understood Area 51. The declassified documents laid out a clear sequence. A remote lake bed in southern Nevada was chosen in 1955 for its isolation, its flat surface, and its position inside a military reservation so vast that the nearest town sat more than 100 miles away. The first aircraft arrived under total secrecy. The U-2 that would photograph the Soviet Union from heights no other plane could reach. The A-12 and the SR-71 that pushed speed and altitude beyond anything the public knew existed. Later came the stealth programs that became the F-117. Each project left visible marks on the surface: new hangars, longer runways, fuel farms, support buildings. The account aligned with the evidence that was permitted to surface. At first, the explanation sounds reasonable. This was a place built to perfect machines that flew higher, faster, and more invisibly than anything known to the world at the time. That is the version most people are taught, and for many years it was enough. But that is where the account begins to crack. The desert does not surrender its secrets to casual glances. For generations, the only views came from distant ridges, where watchers stood with binoculars, or from the occasional high-flying aircraft that crossed the restricted box before the rules were fully locked down. Then the satellites arrived. Early spy satellites photographed the base during construction. Some of those frames are now public. Later came commercial systems whose resolution improved year after year until individual vehicles and the seams on hangar roofs became visible to anyone with a screen. When those sharper images were examined, not only by trained eyes, but by systems built to detect order inside complexity, a different picture began to form. One detail refused to fit. In a sector the official descriptions and older maps treated as secondary or largely empty, there appeared a large, geometrically regular pattern that did not belong to any announced construction phase. The pattern was not a building. It was the surface signature of something beneath the ground, and the measurements that returned from the analysis made the old explanation much harder to accept without reservation. Stay with me, because once you notice this detail, you cannot unsee it. Groom Lake lies in the high desert of southern Nevada, roughly 83 miles north of Las Vegas, inside the Nevada Test and Training Range. The dry lake bed stretches pale and flat under a sky that feels closer than it should. Mountains rise on three sides, forming a natural bowl that hides the facility from ground-level eyes many miles away. The air is thin and dry. The light is unforgiving. Silence is broken only by the distant roar of engines or the low thump of ordnance somewhere out on the range. To anyone looking from outside the perimeter, the visible base looks exactly like what it has long claimed to be: a serious flight test center with long runways, large hangars, fuel storage, and the constant small movements of support vehicles. Security is visible in the fence line, the watch positions, the patrols that move along the inner roads. Everything about the surface says the same thing it has said for 70 years. Do not approach, do not photograph, do not ask. That feeling has been part of the place since the first buildings went up. And for most of that time, the public accepted the visible boundary as the complete picture. The problem begins when you look closer. When the latest generation of commercial satellite imagery reached sub-meter ground resolution, independent analysts began feeding the passes into tools that had not existed when the base was built. Change detection algorithms compared frames taken years apart to separate what had moved from what had stayed fixed. Object detection models trained on thousands of examples of known military infrastructure scanned for shapes that matched underground access points or environmental control features. Statistical routines measured spacing and alignment across the entire flagged zone. The machine was not told what answer anyone wanted. It was only asked to measure what was there. The passes analyzed were those from a 2024 commercial tasking that had entered a private European geospatial archive after the original license lapsed, catalogue reference EU-GEO-ARCH-2024-GL-0942. An independent researcher, Dr. Lena Voss, who had previously worked with declassified corona imagery on a university project in Austria, was the first to apply the full multispectral anomaly detection protocol to the entire western sector stack. In one sector, offset from the main cluster of hangars and closer to the western edge of the secure core, the system returned a high-confidence indication of a subsurface feature of substantial size. The confidence level sat in the high 80s. That single number was enough to make experienced analysts stop and run the data again. The reported dimensions of the main anomaly came back as approximately 2,800 feet along its longest axis and 1,900 feet across at its widest point. Those are not small figures. They describe a footprint larger than many of the visible surface facilities combined. Depth modeling, derived from terrain interaction and shadow analysis across multiple viewing angles and multiple passes, placed the top of the structure between roughly 65 and 140 feet below the present surface. 7 distinct surface expressions arranged in a grid showed spacing that varied by less than 5 feet across the full layout. Angular alignment deviated from perfect by less than 0.3 degrees. When the identical measurement protocol was applied to the visible hangars and support buildings, the variation was noticeably greater. Human construction crews, even careful ones working with good equipment in open desert, introduce small irregularities that accumulate over distance. Here the pattern held steady as if the entire layout had been executed under a single, unwavering control. That was the number that stopped them. Researchers who had followed every available frame of the base for years ran a direct test against the known construction record. They took the declassified project timelines and asked whether any announced phase required or described a buried complex of this scale. The answer was no. They took the historical imagery from the 1960s and early 1970s and asked whether the expected surface signatures of large-scale excavation appeared in the right place and at the right time. The answer, again, was no. The volume of material required to create a space of the measured footprint at the modeled depth is substantial. In the era before widespread GPS and modern earth-moving fleets, that volume would have demanded hundreds of heavy truck movements per day over many months. The access roads should have shown corresponding wear and traffic density. The logical locations for stockpiled or dispersed spoil should have carried visible alteration for years afterward. Those signatures are absent from the historical frames at the scale and location the numbers would predict. The stone was not arguing, it was leaving a pattern. And the pattern visible on the surface did not match the pattern required by conventional construction of that period. Once you notice it, the old explanation becomes harder to accept. The closest match the analysis produced was not what the standard explanation would lead anyone to expect. When the geometry, access distribution, apparent depth, and minimal surface expression were compared against a wide set of known underground military and civil facilities, the strongest parallels were to hardened, deep-level installations built for sustained, self-contained operations. Not temporary aircraft storage, not simple fuel bunkers, not the kind of shallow underground hangar seen at some other airbases where aircraft can taxi directly in and out. The layout suggested something that needed physical separation from surface traffic, something that required controlled internal conditions, something whose existence was considered to justify concealment even from the reconnaissance systems the base itself relied upon. This did not prove that anything beyond conventional classified work was occurring below the desert floor. But it did raise a question the old explanation could not easily answer without adding entire layers that had never been acknowledged in any released document. The mystery did not get smaller, it got wider. To go deeper, analysts examined the additional data layers that modern commercial satellites collect beyond visible light. Multispectral and hyperspectral bands revealed subtle but repeatable differences in surface reflectance and thermal behavior directly above the flagged feature. In certain seasons and under specific lighting, the soil and sparse desert vegetation above the suspected structure responded differently than the surrounding terrain. The differences were small in absolute terms, yet they repeated across multiple independent passes and multiple years. They were consistent with ongoing temperature regulation, air exchange, or low-level activity below the surface. These are not the traces of a static, sealed, and forgotten space. They suggest something that continues to be managed and maintained. The deeper the examination moved, the more the evidence pointed away from a simple support function and toward a facility whose purpose was considered important enough to keep physically and informationally isolated even from the normal documentation channels of the programs it served. And that is where the timeline begins to bend. Construction at Groom Lake began in 1955 under conditions of extreme secrecy. The first buildings rose quickly. The runway was placed directly on the lake bed. By the early 1960s, the base was already hosting programs the public would not learn about for decades. If the subsurface feature was already present or under active construction during those early years, it means the original planners were thinking in terms of a much larger and more permanent infrastructure than the declassified history's record. It also means that whatever method was used to create the space either left almost no lasting trace in the early reconnaissance imagery, or was executed in a way the watching systems of the time were not positioned to capture fully. The Corona satellites and other early assets were not perfect, but they did photograph the base repeatedly during the critical decades. The absence of obvious large-scale excavation signatures in those frames, combined with the clear presence of the feature in later imagery, creates a gap the standard timeline does not comfortably close. One site could be a mistake, but the same signature appearing somewhere else changes the question. When the identical analysis protocols were applied to other long restricted zones inside the Nevada test and training range and to a small number of additional Western facilities tied to classified research, comparable geometric regularities and subsurface indicators appeared. The details were not identical. The scales differed. But the underlying combination of precise layout, minimal surface disturbance, and indicators of ongoing or recent subsurface activity repeated often enough that isolated coincidence became difficult to maintain. In at least two cases, the features were already visible in imagery from periods when surface construction at those locations was still described as limited in the public record. The repetition across sites and decades suggests a deliberate and consistent approach to placing certain categories of critical infrastructure underground and out of easy overhead view. It is no longer possible to treat the Groom Lake signature as a single curiosity. It begins to look like part of a broader pattern in how sensitive work has been protected across the American West for generations. The evidence does not fit cleanly into the version most people are taught. That version is not false. The aircraft programs were real. The engineers who designed, built, and flew the aircraft have spoken on the record. The documents that have been released tell a coherent picture about what was happening on the surface. But the version stops at the surface. It does not account for a subsurface signature of this apparent scale and precision existing in the same place, built on a timeline that overlaps the known programs, and yet never appearing in any description those programs left behind. When the tools of examination improve, when resolution allows new measurements, when analysis is performed without the prior assumption that the visible boundary is also the complete boundary, the picture that emerges is larger than the frame we were given. The desert itself has not changed. The security perimeter has not changed. What has changed is our ability to see what was always there. To understand how unusual the consistency really is, consider what human construction crews actually produce under real-world conditions. Even with good instruments and careful supervision, small errors in angle and spacing accumulate. Over hundreds of feet, those errors become visible as deviations of several degrees or several yards. The grid flagged at Groom Lake shows deviation under 1/3 of 1 degree across its full extent. That level of regularity in open desert during the 1960s or 1970s would have required either extraordinary survey discipline repeated without drift or a planning and execution process that did not rely on the same cumulative human steps. The numbers do not claim to reveal what tools were used. They simply show that the result sits outside the normal variation expected from conventional methods of that era. The same discrepancy appears when the implied volume is compared against the visible record of activity. Creating a space of the measured footprint at the model depth would have required moving a very large quantity of material. In the middle of the 20th century, that movement would have left clear traces, widened or heavily used access roads, temporary construction camps large enough to house the workforce, and areas where excavated material was stockpiled or spread. None of those expected traces appear at the necessary scale in the historical imagery from the relevant years. Either the builders achieved an extraordinary level of concealment at every stage, or the method used to open the space left a significantly smaller surface footprint than standard cut and cover or open pit techniques. Both possibilities sit outside the standard explanation of how the base was expanded. When researchers tested the surface signatures against known examples of large underground excavation from the same decades, the mismatch remained. Nuclear test tunnels at the Nevada test site, for example, were documented because the tests themselves eventually became public. Their construction activity appears in the historical record. The Groom Lake feature carries no such documentation. It sits in a sector described in released materials as secondary or undeveloped. During the same years, the signature was already forming. The absence of corresponding surface evidence in the older frames is not proof of anything exotic. It is simply a gap that the conventional explanation does not close without additional assumptions that have never been stated in any declassified source. The pattern gains weight when it is placed beside similar signatures, identified at other restricted locations. The same combination of geometric regularity, minimal surface expression, and indicators of subsurface activity appears at least twice more inside the broader Nevada test and training range, and once at a separate Western facility, long associated with classified technical work. The scales differ and the exact layouts are not copies. Yet the underlying approach to placing infrastructure underground and protecting it from easy overhead measurement repeats. One instance can be explained as local engineering choice. Repeated instances across different sites and different decades begin to look like institutional practice. The question, therefore, expands beyond a single feature at Groom Lake. It becomes a question about how much of the classified infrastructure in the American West has been deliberately placed where conventional observation would miss it. The deeper data layers reinforce the same impression. The multispectral differences above the feature are small but persistent. They appear in multiple seasons and under varying lighting conditions. They are consistent with continuous low-level management of temperature, humidity, or air quality below the surface. Such management is not required for a simple sealed storage vault. It is required for spaces that are occupied, that contain operating equipment, or that must maintain stable internal conditions over long periods. The presence of these traces does not reveal what is happening inside. It does indicate that whatever is there has not been abandoned or simply buried and forgotten. The engineering implications add another layer of tension. Large underground spaces in desert geology require structural support, water management, and ventilation systems scaled to the volume. In the 1950s and 1960s, those requirements were understood. But executing them at the implied scale while keeping surface disturbance minimal would have demanded either very advanced planning tools for the era or construction methods that differed from standard practice. The precision of the surface grid suggests the planning itself was executed with unusual consistency. Whether that consistency came from early computer-assisted design, from exceptionally rigorous manual surveying repeated without drift, or from some other approach is not answered by the imagery. The imagery only shows that the result sits outside the variation normally produced by the documented methods of the time. The timeline tension remains the most persistent problem. The feature is already visible in imagery from the late 1960s and early 1970s. During those same years, the declassified record describes the base as still expanding around specific aircraft programs. If the underground component was already in place or under construction then, the original 1955 master plan or the immediate follow-on phases included a subsurface element far larger and more permanent than any release description acknowledges. That possibility does not require any claim about what the space contains. It simply notes that the physical evidence visible from space and the documentary record do not align as cleanly as the standard timeline does not comfortably close. The same tension appears when the feature is compared with the known growth phases of the base. Each announced expansion brought new surface buildings whose construction activity is visible in the historical imagery. The subsurface signature does not align with any of those documented phases in either timing or location. It occupies a sector treated as secondary in the older maps and descriptions. Its internal consistency suggests it was planned and executed as a single integrated system rather than added incrementally as needs arose. That integrated character is difficult to reconcile with a picture of piecemeal growth driven by successive aircraft programs. When the analysis is extended to the broader pattern across multiple sites, the question becomes larger still. If similar signatures exist at other long-restricted locations, and if those signatures also appear earlier than the documented surface expansions at those sites, then the approach to hiding critical infrastructure may have been more systematic and more consistent than any single base's public history records. The Groom Lake feature is no longer an isolated anomaly. It becomes one data point in a wider set of observations that the conventional picture of classified facilities in the American West does not fully address. The evidence, therefore, forces a wider question. The visible base at Groom Lake was and is a flight test center. That part of the record is documented and real. The question is whether the visible base represents the complete extent of what was built and operated there. The satellite measurements and the pattern analysis suggest a subsurface component whose scale and engineering characteristics sit outside the descriptions released so far. That discrepancy does not automatically mean anything exotic was or is present. It does mean that the boundary between what has been acknowledged and what remains hidden is not as sharply defined by the physical evidence as the official position has long implied. The geology of the Groom Lake playa adds a further complication to any straightforward reading of the evidence. The lake bed consists of fine-grained sediments laid down over millennia, material that is soft and prone to compaction compared with the surrounding mountain bedrock. Constructing large, stable underground volumes in such conditions requires careful engineering. Shoring systems, drainage to manage any infiltrating moisture, and load distribution designed to prevent surface subsidence over time. The geometric precision of the surface grid and the absence of obvious long-term settlement signatures suggest that whatever was placed below was executed with a level of attention to detail that would stand out even by contemporary standards. In the 1960s and 1970s, when most of the documented surface expansion took place, such techniques were available but were typically reserved for projects of the highest priority. Their apparent use here implies that the subsurface component was regarded from the outset as something that justified extraordinary effort and expense. This returns us to the question of purpose while remaining anchored in what the measurements themselves indicate. A space of this footprint and depth, executed with that degree of regularity and concealment, and displaying signs of continued active management, does not align easily with temporary or secondary support roles. It aligns more closely with work intended to continue across decades, work that demanded isolation from both visual observation and environmental fluctuations. Work whose character was considered sensitive enough that even routine internal documentation channels appear not to have captured its full extent. The visible aircraft programs clearly required hangars, runways, and fuel infrastructure. They did not obviously require a large, deep, precisely surveyed subsurface complex located in a sector the maps and released documents treated as secondary. The mismatch is what compels the broader question. When researchers began cross-referencing the satellite measurements with the body of declassified range management documents and environmental assessments produced from the 1970s onward, another discrepancy emerged. Those papers described surface facilities, runway resurfacing, fuel farm expansions, and security enhancements in considerable detail. They contain almost no reference to major subsurface construction in the flagged sector during the relevant periods. Either such work fell under a classification level that excluded it from even internal range planning papers, or it was managed through a separate authority and record-keeping system that has not yet been made public. In either case, the result is the same. The available documentary record, both public and much of what has been declassified, captures only a portion of what was actually constructed at Groom Lake. The cultural consequences of that persistent information gap have been significant. For more than half a century, the secrecy surrounding the base fueled intense public speculation. Books, films, and endless discussion filled the vacuum left by official silence. Some of that speculation drifted far from any verifiable evidence. Yet the underlying impulse was understandable. When a facility is deliberately removed from ordinary maps and public oversight, people naturally wonder what else might have been removed along with it. The satellite analysis does not answer those older questions. It simply demonstrates that the physical footprint is larger and more engineered than the documented explanation ever described. That demonstration does not validate any particular theory. It does show that tools now available to independent observers can surface details that remained invisible to earlier generations of researchers and to the public at large. This change in what can be seen is itself relatively new. High-resolution commercial satellite imagery only became broadly accessible within the last 2 decades. The advanced geospatial analysis tools capable of processing multispectral layers and identifying subtle, repeating patterns at scale have become practical even more recently. The feature beneath Groom Lake was not constructed yesterday. It was only rendered measurable in a systematic way by capabilities that did not exist when the base was built, or when the first public stories about it began to circulate. The desert has maintained its silence. The instruments passing overhead have started to convert that silence into quantifiable data. Those data points do not match the explanation that stood for so long. The same shift in visibility is occurring at other restricted sites across the western United States. As commercial imagery improves and analysis methods become more widely available, similar questions are being asked about facilities whose surface explanations have also remained incomplete. The pattern is no longer confined to a single location. It is becoming a broader inquiry into how much of the classified landscape was designed from the beginning to remain partially invisible even to the systems that watched it most closely. This wider inquiry does not require belief in any extraordinary claim. It requires only attention to the measurements that are now possible and to the gaps that remain between those measurements and the explanation that was given for decades. The desert has not changed. The security perimeter has not changed. What has changed is the resolution at which we can examine what was always present beneath the surface. So what do you think? Is this simply the natural footprint of a much larger but still conventional secret research and testing complex, kept hidden for standard national security subtle variations in desert terrain and normal infrastructure, amplified by pattern-seeking tools that sometimes find order where simpler explanations suffice? Or does the combination of precise geometry, early timeline indicators, substantial implied volume without corresponding surface disturbance in historical imagery, and persistent active signatures in modern data point to a scope and a purpose at Area 51 that has remained outside the declassified position for reasons that go beyond protecting specific aircraft designs? The desert has kept its silence for decades. The machines above are only now beginning to translate that silence into numbers we can examine. Tell me in the comments. I read every one, and the most interesting theories often come from you. And if you believe there are still layers to these questions that the official accounts have not yet addressed, subscribe and tap the bell so you are here when the next mystery refuses to stay buried. The numbers do not claim to reveal everything. They simply show that the explanation we were given for so long is no longer the full picture the evidence supports.